Anybody have any questions for Matt on his presentation before we move on? Okay. All is klar, as they say in Germany, right? Okay, great. So the next part of our presentation here is an OEM discussion about the future of connected vehicles. And I'm going to ask that Graham and Katrine and Matt all join me on stage. So come on up. So welcome to the stage. We have Matt's got you guys are going to share a handheld. So why don't we just start by you introducing yourselves. We already got introduced to Matt, but Katrine and Graham, why don't you introduce yourselves for the audience?
Hello, I'm Katrin Mattis. I'm the Chief Technology Officer of the Renault Software Factory. That's the software organization in Renault. And I'm really glad to be here and have again a face-to-face event and hopefully be able to chat with you during these few days.
Hi, Graham Smethurst. I lead up the BMW research team for, in German you'd say, E-Striche architecture, which is basically everything in the vehicle that supports but doesn't deliver customer functionality. So we basically take care of the underwear, you can say, within the vehicle. I was in Geneva at day one, back in 2009. And it's great to be back in Covisa in a different context. And when we get to do our pitch, I'll try and explain why we're still here.
Thanks, Graham. And now I'm representing Ford Motor Company, where I joined 6 months ago. My role is head, director, global technology strategy. So my role spans ICE motors, EV, in-cabin, all of the different technologies that we will need for that holistic experience going forward.
Great, thank you. So we're going to start out with the Renault presentation. The way we're going to do it is a brief introduction, sort of setting the perspectives of the three organizations, and then I've got a few questions that we're going to ask, and then we'll take, if time allows, we'll take a few questions from the audience as well. So, Katrina, you want me to do this, or would you like to? Okay. Yeah, okay.
Yeah, just as an introduction, to share with you a bit of a vision where we are today and where we are heading in the future of connected car. So first step, I call that car comes to cloud, meaning that the car, by extending to the cloud, it will be able to offer, first of all, a better user experience. So one of the examples is embedding Android Automotive with the Google Automotive Services in the car and no longer having to replicate smartphone to get an equivalent experience. And that's also thanks to part of the processing and part of the data actually residing in the cloud, whether it's for the Google Assistant or for the Google Maps. The other thing is that we have also many digital devices, and that thanks to deploying application on these digital devices to have our digital life continuum, we can have application running in the car, but also on a smartphone or even in a smart home. And then we have also expanding a lot of connected services. And many of them maybe we don't even really know of today. And that's really a whole roadmap that's possible thanks to car data coming to the cloud, being processed in the cloud, and some result coming back to the car. And so it's a first step where we can see the car extending to the cloud and leveraging actually cloud compute capacity to bring a new experience, new digital experience to the car. So the step afterwards, I call that cloud comes to car. And so we start about talking about software-defined vehicle, centralized architecture, high-performance computing. some of these terms only a few years ago were reserved to server and cloud. So I was at Intel before, and when we were talking about HPC, we were talking about our data center group, and not about anything embedded and like in a car. So we are talking now also about cloud technologies coming to the car. Virtualization, which is already a reality in cockpit domain controllers today. But then this is going to expand actually to whole function, like also Matt was referring connected ADAS, also coming to a virtualized function. The step afterwards will be embedding containers and orchestrators, and that will even bring more upgradability. So today we have over-the-air update, but container will make these even more dynamic and more frequent in terms of update. And so this will allow us to have hybrid services, and now bringing many more services actually embedded in the car, and have dynamic load management between the car and the cloud. And so going back now to Covisa, what we see is this future is data and service driven. And we want actually the car and the whole ecosystem to be able to interact. And the future of this software-defined vehicle, we don't even know what is going to be all the application and services. So it's a potential for the future. And so having an open alliance with an open specification that is able to evolve in the future, I think that's for us a very important starting point to build this future together.
Eventually. There we go. So in that kind of description of where we are now, where we think we're going, in a very similar way, and I agree with everything that you've just said, as you can imagine, we have subtly different use cases at times. In Ford, we have a big Pro division, transit vans and the like. And we have in the US, in European standards, giant pickup trucks, some of which, as you've seen today, are now electric. And this means that we work with fleet operators from a logistics perspective. We work for people that tow. We work with UPS and FedEx. And that's not actually that different when it comes to what we have to build into these vehicles. And Ford, you know, from the Lincoln brand, from the cars as well. And it almost goes to show exactly what Katrina's just said, where for us, spanning these different markets in different points and different geographies, it's still about data. And it's still about the services that we can provide. And it's still about how those services in the future aren't just in the cloud, and they're not on the vehicle, they're kind of with you. With you if you're operating it as somebody that owns the truck for work, or with you if you're a family at weekends. And the challenges that we have are, as I indicated earlier, as many of the other members have indicated, it's about keeping up with the expectations. And I think where we're really focused in the future is that Ford vehicles, they don't live in isolation. They live with all of the other OEMs. They drive around cities in different countries across the globe. They interface to charging stations and traffic lights in the same way as a Renault or BMW may. And it won't be a reason to buy a Ford because it does that. It will be a reason to not buy a Ford if it doesn't do that, so that we have no option and it's the right thing to do. Graham?
This is going to be a little different, but forgive me. At BMW, we've been debating basically what's a connected car and where is VSS as a data description relevant to that connected car. In part of my time between withdrawing from Geneva and coming back to Covisa, I spent a significant amount of time in Berlin and Brussels talking about data. And it's very clear that not all data is the same, and there are many stakeholders who want access to different types of data. So what I'm showing you here is BMW thinking, where we talk about a number of data touch points, where people might want to access data. Here, purely from a vehicle point of view. And when you go from OBD through eCall, through charging point, vehicle to traffic infrastructure, vehicle to mobile device, or internal vehicle interfaces like to a hosted OS, be it Android or Harmony or whatever it might be. And then the need to train things like artificial intelligence algorithms. There are many usages of data. And you can see from this picture that we've already started to position VSS as a data description, in terms of those data touch points. Now, I mean, one thing that we would want to discuss within the context of Covisa is, do we have a similar view on this picture or not? Are we talking about the same topics? Because if we're not, it's going to be difficult to find solutions, because we'll just go round and round in circles. Now, if we look at a future architecture in terms of what would a board nets architecture look like, or a vehicle network architecture look like to support these touch points, if we go back to basics and you look at the ASIL requirements that we have across the board nets architecture, we make our life interesting, or difficult, can I say, at the moment, because we mix together ASIL relevant and non-ASIL relevant functionality. Now, that makes it really quite difficult to update a vehicle, because you have to go to the most safety relevant aspect when you go to your validation process. And of course, if you want to validate a braking system, then it takes more time and effort than it does to validate a, I don't know, Spotify app. Yeah. So one of the things that we're looking at the moment, and these three circles at the bottom, the red, the amber, and the green, represent our future domain architecture. Now, the way that we're thinking at the moment is that VSS has a relevance in certain parts of those vehicles for certain parts or certain touch points. So we're not looking to reinvent the CAN bus and FlexRay. We're looking to augment those networks and use the power of VSS to introduce consistency. Now, there's no point in BMW doing that on their own. Yeah, that's why we're here in Covisa, because we want to do that in a way that we can produce some sort of common language to interface with all those people who are interested in accessing the data. But what's important to remember, here's one function, remote door unlock, for example. A remote door unlock function is spread across many controllers and many different parts of the architecture. Now, where is VSS spoken and where is CAN spoken? It's important to understand the difference. Now, from BMW's point of view, VSS is not relevant on the left-hand side of this picture. Yeah, VSS is relevant on the right-hand side of the picture, and it's the right-hand side of the picture that we need to update fast on a regular basis with acceptable effort and acceptable cost. And I guess what this is accepting is the fact there are parts of the vehicle that are updated less frequently and with more effort. But by getting this differentiation and applying VSS appropriately, this is what we as BMW are, this is why we're in Covisa. Yeah, so you could say IVI is the green part on the right-hand side. Geneva succeeded going from fragmented to Linux to open source. Yeah. Now the challenge is to establish this green line and to introduce VSS as a standard, difficult word, as a common language. I've done a number of other examples here, and you can see here by brake-by-wire, completely irrelevant in the context of VSS and in context of Covisa. This is just a BMW view, but this is what we want to discuss with you guys. heat, yeah, that's it.
Okay, you can hold on to that. Thank you, all three of you, for that. And I just have a few questions to spearhead the discussion, because now we want to move into a little bit more of a discussion activity. And if you have questions rolling around in your head that you'd like to ask, clarification questions or whatever, recognize that there's sensitivities to proprietary things. And so we're here to preserve antitrust activities and make sure all of our activities are within the antitrust context. And we certainly don't want to ask questions that would cause the OEMs to feel uncomfortable about answers in that context. So be careful with that. But let me just start with a couple of questions. Every industry has opportunities and also challenges, and automotive is no different. When you look ahead a few years and look at the significant opportunities that connected vehicles are now giving OEMs and their customers, their drivers, their occupants, even commercial vehicle occupants, what are the greatest opportunities in your minds that sort of come to your mind when you think about the future of connected vehicles from an OEM perspective?
The big one from the Ford perspective is that kind of near instantaneous digital feedback loop from what a customer is doing to a developer's desk to update it. And there's the famous example from Tesla, where Tesla on their active cruise control with their radar sensed that people were complaining about active cruise control when going around a tight bend and it was braking because it saw the concrete barrier or something in front of it. They didn't sense it from the vehicle immediately, they sensed it by people complaining on Twitter. Some would argue this is why Elon's buying Twitter, not the purpose of today's discussion. But from that social media analysis, they then compared that to all of the different pieces of data, all those low-level signals that they could get access to in the vehicle, and they broke those safety-critical signals out of the left on Graham's line, and they took that into the cloud. And from all of these different vehicles, they could compare the different signals to figure out what was happening. And from that, they then could reproduce it in a matter of hours. And from that, they did a software patch. And from that, they did an OTA update. And this is why, from a Ford perspective, it's actually really critical that we can spy. We can look at what's happening in safety-critical systems on things like steer-by-wire at a macro level in a cloud using similar technologies without affecting those safety systems. And so to go back to the initial question, it's about having that detailed feedback loop so that we can really polish all aspects of the experience, not the IVI experience, but the driving experience, or the way an autonomous car or an L3 feature on highway actually works. What is that ride and drive that the robot gives you, and what do people think about it? And how can we get all that data with the IVI so we can make the best product decisions?
Maybe to continue along the lines, and I'm maybe a bit biased because I'm a CTO of a software organization, but I think one of the greatest opportunities of future cars is software. And the current limitation we have is that software is built in ECUs, and so there is no global view of the software. And software-defined vehicle and centralized architecture change actually that view and make the car much more upgradable. And that means that the cars will be able much more to evolve over time, like actually smartphones did. With obviously we have to manage the safety. That will be the next question on the challenges. But staying first of all on the opportunities, I think that's one of the greatest opportunities, is having cars that are much more upgradable and that you will have content in future cars that we even don't know about today. And so this is, and get it also much more quickly, as Matt was saying. So you don't need to wait for a year or longer, or even go back to the garage to get some update of software. It will be much more dynamic.
Life right now is just too difficult the way our vehicles are architected. It doesn't matter whether we're trying to integrate a karaoke app or a level 3 automated functionality. The common language is the signal. And unfortunately, all the signals in BMWs are not the same from one generation to the next. And I'm damn sure the signals aren't the same in a Renault and a Ford. So we for the things, we term it the digital experience. Yeah, and you can debate what's the digital experience, but within that digital experience, we have to be able to do things much faster and without the same amount of effort and risk. And the only way we can do that is by no longer talking in signals, talking in data. And basically, if you look at all the connection points, provided the connection points are all talking data and not signals, we get a great deal more reuse and efficiency. And that's what we're searching for. I'm not claiming by any means that we're there yet, but that's the quest.
Okay. As I said, every industry has opportunities and challenges. What are the challenges facing OEMs as they think about maximizing the future of connected vehicles and services and so forth? Yeah.
Of course, as an OEM, as you start to open up the vehicle to make the capabilities of the vehicle accessible, there are two big challenges. One is at the same time the vehicle needs to be secure, so it's safe for the occupants to use. And the second one is simply data privacy. So it's going to be impossible for us to open up the vehicle without, at the same time, coming up with security and access methods that protect the car, the customer, and all the people involved in the liability chain when it comes to delivering those vehicles. So that's something that we really need to spend some time on. We can't talk about opening up without talking about some degree of management and control for who gains access to that data, when. And I know this is a really difficult discussion. Like I said, I spent time in the political circles. No one wants to hear this, but if we don't address it, then it will not be possible to open these things up.
Yeah, so I would say there are many technical challenges to build the next generation cars because it's fundamentally changing the architecture of the car. But maybe the biggest challenge ahead, and I witnessed that within Renault Group, is changing the culture of a historical automotive company to becoming really more a tech company, a software-driven company, and adopting new ways of doing. And that's not only agile ways of working, it's adopting new technology, is being less risk adverse. So obviously we still want to build safe and secure cars, but there's a whole culture, I would say, in historical automotive companies that need to change if we want to build these cars of the future.
Okay, I agree completely. The biggest challenge that we have, we can dream a product. Any one of you, I can have a conversation now and we'll have this amazing L5 flying autonomous car that does teleportation. We do not have the people, the culture, and the processes within automotive. And if we think about how the automotive ecosystem is, it's not just even me as an OEM, it's about all those different tier ones and all their sub-suppliers. And we talk of software. In some ways, this is the hardware as well. And how do we start to stop thinking about job one, stop thinking about when the software freezes, and start thinking of this as a continuum? And dare I say, some people talked about that in 2009 at the start of Geneva, and we still not got there. So I think we'll solve one technical challenge, and another technical challenge, and another technical challenge. But unless we actually solve the overall challenge of having the people and the culture and the speed of development, which isn't just about the technologies we implement in the product, we're not going to be as successful as we need to be. And in many ways, I would argue that we've almost got too many software developers, or desire for too many software developers in some of these companies. And tomorrow I'm going to present at another conference. And some of you from a technology, from a multi-core CPU perspective, know Amdahl's law, where as you put more cores in there and have more processors, it becomes less and less efficient. I am 100% sure it's the same with software developers. When I joined Ford 6 months ago, they said, we need 2,000 extra software developers. I said, the only thing you will get with 2,000 extra software developers is no working software. I stand by that, honestly. But that's where I think Geneva can really come in. Ding! Covisa can really come in. Thanks, Graham. How can we not only get the technologies, but make it easy to implement, easy to maintain, so that just like Geneva, we're not recreating the wheels of operating systems or data models or middleware? How can we reuse those so we can focus on the applications, the wider range of applications, spanning the car, the device, and the cloud that actually our customers care about?
Excellent, thank you. So the next one is a little bit of a different approach here. When Geneva was launched, purposefully, we talked a lot about non-differentiating features versus brand-oriented features. We had this little dotted line that says everything below the line is fair game because it's commodity, it's across OEM, it's across supplier. We want to find common ways of doing that. And everything above that line, user experience, branding, that sort of thing, was sort of verboten in Geneva and now in Covisa. So the question is, if data informs services and services are delivered to in the vehicle, in the car, is the whole process of going from data to services to delivering services to your customers, where is the proprietary line drawn there? And how can an open alliance like Covisa participate in that if what we're shooting for is something that
Well, I have this view,
yeah?
formed from my observations of Microsoft versus Linux. And I honestly believe that whatever a person is willing to open is where that line needs to go. And if somebody else doesn't want to take it, that's okay. Because if you think about Linux, were they crossing the line with openness because they were invading on Active Directory and Linux and Windows servers and these other elements? And I think history is littered with companies that felt that something was proprietary for too long. If anybody has a Nokia phone, etc. So it's like, how can we not worry so much about this ever-changing line where in reality it's about the business model of the company? And if I want to open source something, I will. If Graham does, he will. And that's okay, but not everybody has to use it. But in many ways, it shouldn't be verboten in the same way as we had intensive arguments over, well, if we're not doing HMI and graphical user interface, what about graphical frameworks? What about the interfaces to middleware to graphical frameworks? What about speech? Is speech different from another type of user interface? If we get into those discussions, we're probably spending the energy in the wrong place, especially when it comes to what we're focused on in Covisa, which is the data models, the tools, how it could be used for a range of future stuff that we don't even understand yet.
So I think that if we take an example like the Android or Apple ecosystem, is when you expose interfaces, you give the opportunity to an ecosystem to build content. And so the value and the IP is finally in the content and the application. It's not in the fact that you expose an interface. And so specifying common ways to share data and share interfaces is really an opportunity and gives a potential to build this rich content and federate a whole ecosystem, even create a whole new ecosystem of application and services that can be built on top of that. And I think this is, for me, really to discuss together is what enablers we can build in Covisa to build this whole new ecosystem based on data and based on service interfaces together in our alliance.
I agree completely. I said in my short introduction that I basically deal with the underwear. Yeah, I've got thousands of colleagues at BMW who work on customer functionality. So our interest in Covisa is really, it's the raw material that is data. I don't really care what people, under privacy and security constraints, we don't care what people do with that data. You know, if you want to apply your IP based on the data, that's fine. There has to be some degree of expectation management, though. And that's why, coming back to the touch points I had on the vehicle, if it's someone's expectation that they will get data in the back end at 20 hertz, it's an unrealistic expectation. So please don't try and build an app on the back end that has that requirement. Yeah, and we do get asked for such ridiculous things sometimes. So as we go through the various touch points on the vehicle, each of the touch points is based on a common data description, but the technologies you apply and the expectations that you set on those touch points need to be understood. And that's what's important to us. So not the application or the service that you develop, but the functionality that is realistic on a given touch point. And that's important. Yeah, so we certainly don't see this. The only one size fits all here is the data model itself. Yeah? Everything else is dependent on the technology we choose to apply to a given interface. And the technologies are going to vary. And we're going to have an interesting discussion within Covisa. How far do we go within a deployment model and the implementation of a technology, maybe as a reference? But it's very difficult to come up with a definitive statement for what technology should be applied on a given interface. So, I mean, that's from a service and apps point of view, but let's get to a common understanding and a common expectation against each of those touch points.
Okay, at this point, I want to open the floor up for questions. I do have one last question to close with, but does anybody have any questions for our panel? Yeah, you can step up to the mic here if you like.
Is this working?
Yeah, that's fine.
I'm Jeff Reed, new here, came from Google, so I specifically work as a product manager in Android Automotive Operating System telemetry. So my question for the panel, and you can come up to me afterwards later if you want, if you don't want to share, but I really want to know what type of data are you looking for from the vehicle, right? Like you spoke about the example with Tesla and like the automotive adaptive cruise control and okay, this data. So obviously the type of data you might be looking on that is, okay, at what point and what GPS point was the ACC disengaged, right? And so you could pull that data and obviously make some software tweaks if you want. But what I'm really trying to get at is kind of, we're still building our strategy. So it'd be good to get information from you, who are the customers, like what type of stuff are you looking for as far as telemetry data coming off the vehicles? Because we're still getting our strategy together and building. We're like right now, well not right now because they're asleep, but we have software developers in Mountain View building this stuff. So the earlier you can let us know, the better a job we can do. And eventually we'll probably go beyond just the IVI piece. Thank you.
Go on, Graham.
I mean, what we would love to do is use all of your Android phones as remote sensors.
And
so all the data that you gather from the phone we could use that to augment what we have in the car. And on that basis, I mean, we could have, this is a two-way conversation in terms of the car has a series of sensors, the phone has a series of sensors, and by fusing them together, you've got a fairly compelling set of sensors. Yeah, so I mean, I would love to have the conversation that says, how do we enable this exchange?
Mm-hmm. And if we can get Ford at the table as well, so we have a desire to have all of the information from the Android handsets, but we'd love to know more about how people are using Google on the web as well. So we can get all of the data that Google has and augment what we're getting from the vehicle. and if it helps, we can probably take a poll in the audience and
I mean, one other point. I mean, at the moment, if the automotive industry wants to integrate or host an operating system like Android Auto, then you guys give us the VHAL, and we basically we feed the VHAL with vehicle-based data. It would be cool to know to what degree or how far would we need to go as a Covisa alliance to get to the point where we could say, look, here's an interface, and we could basically make the VHAL interface redundant. Mm-hmm. So we have an interface defined between us, and we as OEMs commit to supporting the interface that we've standardized within Covisa. Why would we want to do that? Because at the moment, I've said life is difficult, but you know, Android is one of the operating systems that we might want to integrate, but there are other operating systems in other markets that we also need to integrate. So if we could have an automotive interface, which we don't yet have, and we could work with ecosystem partners to introduce the different operating systems, it would make our life a lot easier.
Yeah, so I totally agree. It's about what we try to do together is to standardize a data model and standardize interfaces. So Android Automotive today has obviously built on AOSP with the SDK and build application on top. But that is mainly infotainment-centric. So going beyond infotainment, going more on generic services, obviously fleet services, other services, there are interfaces to build. So if there is openness for collaboration to define the access to the data, like Graham said, on a common data model, and also define common APIs so that we don't duplicate the work, and that what feeds in a future Android Automotive SDK for services can build on the VSC or whatever interface we define together, I think that would be a great achievement.
It's absolutely spot on. For me, the question is not what data do you want to expose, it's how can I enable you to expose any data as and when you need to. And my generic answer, my CEO asks the question all the time, is what data do you think you can get off the car? It's like, I want to take all of it or none of it, and most likely somewhere in between, but that's going to change with time. So for me, it's not a signal data model by data model doing this, but it's how we can have technologies, partnerships to evolve so that as and when we get a new piece, we can expose it or choose not to. It's more about the system than the specifics.
Please.
Hi, I'm Christos Papadopoulos. I'm from the University of Memphis, maybe the only academic here. Maybe there's others. Please come say hi. So I'm really enjoying the meeting. So Memphis, Matt, if you're ever at Blue Oval, please drop by. I'd love to chat. So to continue with the discussion that we just had, I'm going to ask the question, as Graham said, that very people want to ask, and that is, when it comes to data, how do we support things like the right to repair? You know, the third-party, outfits, companies who want to use that data, especially in the face of measures like what came out of Massachusetts recently that passed laws that customers need to have certain access to the data out of our cars. So how do we do this securely? How do we do it with obeying all the privacy issues? How do we enable that ecosystem to thrive at the same time as the automotive space?
And in many ways, I hope Covisa is part of that solution. Because what it can't be is Graham on a 5-year trip to Brussels or Berlin, and it can't be Ford just doing what we want. It's going to take the collaboration in all of these different countries and an understanding of what the potential prioritizations, the potential principles that we need to apply to this data are. Because I've spoken to dealerships in the past. Oh, I need a right to repair, therefore I get all the data forever. Really? So it's what is that line in the sand and how do we figure out what that is? But I don't think that any one player can truly answer that. And I don't think we'll get it right the first time round.
This is why I drew this picture. There are different types of data and the different purposes for the use of the data. I think the big discussion to be had is the difference between I have the car in a workshop, I'm connected to OBD, I'm doing diagnosis. Yeah, the customer isn't in the car. I don't have the same safety issues or concerns to address. I can do what I need to do to validate, to diagnose, to repair the vehicle. When you place OBD type requirements on a cloud type interface, you're asking for 20 hertz update. Who's going to pay for the transfer of the data? It's illogical. But it's a long-running illogical discussion. It's very heated and it's very passionate, but that's why I drew this picture, because I think this is something that we need to discuss early on in terms of, is it in scope? Is it out of scope? Is it something we want to deliberately address? I mean, the legislation is in place to handle this. Yeah? We're not going to question the legislation, we comply with the legislation. We make available to the third parties what we make available to our own franchise dealers. That's the rules. We fulfill the rules. But it is a discussion we need to have, because we could really rat hole on this and just talk about diagnostics and fail to address, real interesting topics like a discussion with the Google colleagues, because we circle around this topic that we know to be, you say burnt earth. It's just a really tough discussion. But if we bring it in scope, it's going to be a major distraction, my opinion. But clearly, difficult topic. But that's provocative or not, that's the purpose for this picture, because on all of these no entry signs, there is existing legislation. There are rules that exist, protocols that are described, rules that we follow. On the others, that's open for discussion.
Yeah, and I think the RMI tries to solve part of the issue. The thing is, once you have regulation, it becomes quite rigid, and it doesn't necessarily evolve with what the customers really want. And so the challenge is really to build the services that go much beyond repair, that really bring customer satisfaction. And one of the points, and I discussed with a good friend of mine who actually bought a Tesla, what brings his customer satisfaction is that he doesn't have to return to a garage to get problems solved. He just gets a software update. And so that's very different from getting data from a diagnostic interface and having to return to a garage. So the right to repair, maybe in a software-defined vehicle, will be very different compared to what we have today with our current cars.
Yes, please.
Hi, this is Thomas from Mercedes. I have one question maybe for Graham first, because you said that with every vehicle generation, you basically start off again by mapping vehicle data to the interfaces. And you said that's maybe similar with Renault and Ford as well. And if this is an OEM-wide challenge or inter-OEM challenge. So what is your approach to tackle this right from the beginning when you start off with a new car line to give a continuity of vehicle interfaces?
I think one of our big challenges is our challenges and strengths is our history. We never start with a blank sheet of paper when we design a new vehicle, unless you guys are different, and then full respect. I mean, our Baukasten, yeah. First metric when you design a car, how much reuse can you have? And that reuse brings with it the domain architecture communication to a large extent. So, I mean, of course, you go as far as you possibly can to have continuity and compatibility between one generation and the next. But the differences are enough to make it not quite the same. And not quite the same means you're back into the same processes and cycles that you've always done to make sure that when you sell the car to the customer is happy, the car is safe, etc., etc. And that's why, I mean, in this picture, I mean, we've decided we're not going to boil the ocean. Yeah, we're not going to revisit CAN and Flex and LIN and say, right, okay, our first target is to replace those protocols with a VSS-based payload. Yeah. At the same time, we recognize the fact that VSS in the vehicle, in the back end, on the various touch points, has great potential value. So, I mean, again, I think each OEM they will decide their own migration path. They will decide whether they migrate at all. Yeah. But, I mean, this shows basically a migration path, saying what works and doesn't need to be updated so frequently, leave it alone. Yeah. That's not to say that in future you might not choose to address it. And I mean, interesting discussions with AutoZar colleagues. You know, they'll come from the signal side. They say, well, guys, can you replace your signals with VSS? But then the discussion between the OEMs and the tier ones, you're talking about standardizing the vehicle architecture, which is a really scary proposition. And you have to ask yourself, well, what is the benefit? Why would you do this? Yeah. Whereas here you look at it and go, well, you're doing it because we need to update with acceptable effort as fast as possible, and therefore we select certain parts of the architecture to address. If that's successful, and we don't know yet, but if that's successful, then you may choose to move further left on this picture. But we're not brave enough to take that decision right now because we don't know. And I'm sure, you know, I think it's important that each OEM has the possibility to take their own decisions as to when and if they choose to take this approach. But the basis is the data model. And as long as everyone agrees that if we migrate, when we migrate, we follow the model, then Covisa has a great opportunity to add some real value. Yeah, so that's our logic.
Yeah, so I can just share a bit of experience because before joining Renault, which is now almost since 5 years, I was working 10 years on Android products, first at Texas Instruments and then at Intel. And so when we were talking about data, we were talking about different layers, service interfaces up to API. And so when I came to Renault, I discovered the CAN interface, very low level, signal driven, and all the constraints that come with it. Because if you want to add a signal, then you have to think about the bandwidth of the bus, and then you have a lot of safety requirements. So it's sort of a nightmare for someone coming from software to want to add actually information if you want to build a service or application that is quite far away from the data, and that's actually the ECU where the data originates from. And so bridging actually that and getting away from the signals, going closer to data and service-oriented architectures This will, I believe, solve the problem that we face today, that we have thousands of signals that are actually different from one architecture to another.
One more comment. I mean, if I have a discussion with one of our digital developers and they say, I want engine speed, yeah, first response, which engine speed? Yeah, and that's the problem we've got. Yeah, that's our history. And I think the challenge that we have to face here is we will say, okay, within our tree, we have an engine speed. Yeah, the question is going to be, so, which engine speed and how do we describe it? And then when someone comes along and says, yeah, but that's not the engine speed I want, then the question is, okay, so what's wrong with the one that we're presenting? And if they come back and say, well, it's the wrong latency, or then the question is, are you working on the right touch point? Yeah, or do I need to change engine speed and come up with a second version? But I mean, roughly on the left-hand side of this green line, there's probably 30,000 signals. On the right-hand side, we don't know how many yet, but if it's any more than, I don't know, 1,000, then we've probably got the wrong things in the VSS tree. And I think we have a regular discussion in terms of, do we add a VSS leaf to the tree? And we're making a big mistake if we're moving towards the board nets database on the right-hand side of this green line. Because the idea here is to have clear differentiation. And if I end up with 30,000 on the right-hand side, then I don't have VSS anymore.
And other OEMs may be looking at it that you have the 1,000, which are generically accessible. But if you have a solution, how could you enable the other 29,000 and an extra 2,000 virtual sensors as well? And I think this is some of the challenge. And this goes back in almost to the privacy and the security of each of those signals. Well, I'm in the same place as Graham. I do not want the clusters team picking between the 12 different engine speeds and then asking why they haven't got one on an electric vehicle. Because that's the situation we're in at this point. So I don't want that, but at the same point, we want one solution where we could have 30,000, 40,000, 50,000 private pieces that nobody else should see, and we use it as part of our capability that have APIs that we translate across. So we almost need a technology that can do everything, but limit for some of the needs of the developers in some OEMs' perspectives.
VSS has to simplify the problem. And if it doesn't,
and I think it's simplify in two ways. It's simplify the standards for the people that are developing the IVI solution, and simplify the ability for the guy that does care about the 12th piece of data from an engine speed to get that at the appropriate time.
I think, Catherine, it was you yesterday, you said, you know, when people talk about Ethernet and IP, they say, give me engine speed. They don't care where it comes from. Just give me engine speed. And that's where we need to get. You don't need to be addressing the last ECU on the, yeah, just give me engine speed. Change the color of the interior light. Lower the window. That's where we need to get to. Yeah, Matt yesterday said, yeah, but we've got snow plows. And I said, well, we haven't.
Yeah. So we're having a snowplow signal, guys.
But that doesn't mean we can't have. That doesn't mean we can't have snowplow in the snowplow up, snowplow down in the VSS tree. Yeah. We as BMW will never populate it.
No, and
Matt will. So.
And I don't want a 16-bit integer value of snowplow position. That was the other comments that we.
Okay, real quickly, one last question, and then we'll close with the last question from me. Go ahead.
Thank you for letting me ask a second question. Graham, I like the line that you presented over here. It gives a good context in terms of having a conversation. I want to ask about security. And why is it that, so CAN and LIN and all these networks, they don't have security, right? And it's very hard to put security in them. Why is it that the security requirements for CAN and LIN and so forth, why don't they push that line much further to the left, and maybe all the way to the left?
Okay, I don't really understand the question, because like you say, OBD was designed to enable open heart surgery. Yeah, and that's why the vehicle should be static in a workshop when you use it. Yeah, because implementing security, privacy, etc. that's not how it was originally designed, and I think we all know you can't retrospectively introduce security. You either introduce it, you design it in, or you don't have security. So the logic here is to say we need a secure space in the vehicle. And the question is how to introduce that secure space. The logic here in this picture, effectively, what needs to be secured is firewalled by the yellow thing in the middle. Yeah. Then we get into an interesting discussion about read and write access, because if you want to write to what's on the left, you need a method, an approach, a policy, a solution, whatever you want to call this thing, that manages such an access. But again, I mean, it's a case of where is it logical to make a change? Because like I say, we won't start. Unfortunately, it's impossible to start from scratch. Yeah. So if you were going to apply a change, where is the most efficient point to apply that change within the existing architecture? Our opinion right now is firewall what needs to be firewalled and open up what we think most people are actually interested in, which is what's right of that green line.
And I would add to that, it's also a matter of whether you're talking about legacy architectures or whether you're talking about the more centralized architectures. Because the problem is that as long as you're CAN-LINK FlexRay based, you have the bandwidth that is built in today. And it means that you cannot add, you're not open bar extensive to data that you can pull from the left to the right. That will change in the sense that when more functions get centralized in high-performance computing, and that naturally more data will be resident there, and also more data from sensors will be able to get there. And that's, as Graham mentioned before, also linked to more standard deployment of Ethernet backbone, higher capacity, and then we obviously need to manage, because there's the security, the safety relevant aspects, and then there's cybersecurity. So once we centralize, it's also higher vulnerability to that data, and that needs also to be correctly managed, not to have an architecture that is then open to a whole lot of cyber attack just for the sake of getting data out of it.
Okay, 1 minute answers. All right, so here's the question. How can Covisa members support your visions of the future, of connected vehicles for your organization? How can Covisa members help you realize those visions? Yeah, I would say in the vision of building an open ecosystem and not knowing today completely, as I said before, what the content actually will be of these future vehicles is help bringing application use cases where we can verify together that the common data model and data catalog we're building, we have the right data inside it, and also the interfaces for services to build are actually the services that support your vision of UC in your organization, what you want to build it as future services, future data-driven architectures, whatever.
It's simple. It's the same discussion as we had in Geneva. It's contribute. Say something. Don't just spectate. And like Catherine says, when we come to talking about what is the tree, what needs to be into the tree, what are the relevant technologies for a given touch point, etc., we need your input. Because the fragmentation that we currently have in many different directions just makes life really difficult. So let's try and remove the fragmentation. And we can only do that when we know what you guys would like to see. This is no blank check in terms of ask and you get it. Of course, it's going to be an interesting discussion. But if you don't ask, then we can't comment.
I don't think that this tree is going to solve all my problems. And in reality, I think it's exactly the same as contributions. It's contributions to the VSS and the surrounding data model challenges, and contributions where companies, member companies, see value in other spaces. Because this is, as we said at the very outstart, this is the Covisa alliance that's aiming to solve many of these different issues we have on these future connected vehicles and the cloud space. And we've got people later in the week talking about payments and charging interfaces and. Some of which will be solved with VSS, some of which won't. We have an active security group that's looking far beyond VSS. We have active participants still looking at infotainment and various pieces there, and it's all valued. And that's where I, as an OEM, representing Ford Motor Company, see the value of Geneva that we can have. Covisa, amazing conversations about VSS, amazing conversations about data, which is the piece that will help us accelerate all of these other pieces. But it's not just about VSS, not for us.
Great. Okay, let's thank our panelists.